Now in this module, we are going to see what a web crawler is, and if you will have to design web crawler, then how you are going to be doing that. Okay. So when you talk about web crawler, as the name is saying, crawling, what does it mean? It is going to go from one place to another. So when you talk about web crawler, so that is that type of a software which we use when we will have to browse the internet and we want to collect all the data from all of those websites automatically. Now what is the main purpose of the web crawler is, that is to visit the websites and then download all the data from all the websites on the internet. Like let us say we are on our website 1. Now from there it can be having link for the other websites, some website 2, website 3, website 2 can have another website link and so on. So what the web crawler is going to be doing, it is going to go from one place to the another and it is going to be collecting all the data. So that is how a web crawler is typically going to be working. Now we will see like how a web crawler is going to be working. So like, if you will talk about any of the website, okay, like let's just take the example of Microsoft.com. Now let us say I am at this website and I want to start crawling. So what I will be doing, firstly, I am going to be visiting a specific website. In this case, I am visiting this website. Now what it will be doing, it will be downloading all the content. So it will download all the content from here, right? So on this website, what it will be doing, it will see what and all other links are there. So this website can be having link to the other websites such as your LinkedIn. It will also have the link for your Google. It can also have link to your Wikipedia. So all of those links are also going to be there. So what web crawler is going to do, from Microsoft, it will first download all its data. From here, it will first go to LinkedIn. It will download all the data. Then it will go to Google. It will download all the data. Then it will go to Wikipedia. It will download all the content. And if after this, if we have something else, so it is going to be downloading all of that data as well. So this process is actually like, if you guys remember, some time back we had that coronavirus. So what that was actually doing, so initially one person was having that, correct? From one person it got infected to other persons. Like this person infected 3 person, from 3 it got spreaded even more. So that is how that virus got spread all everywhere, correct? So you can actually link the web crawler with this example for your better understanding. Okay, so similarly, like, when you talk about web crawler, so what we do in this one, we are going to be initially having one URL. From that URL we are going to go to the different URLs, and from there we are further going to go to the different URLs available to us. So that is how typically a web crawler is going to be working. So this is what the major purpose of web crawler is, and that is how it is going to be collecting data from different websites. Now we will see why web crawler are important. Like, we understood what it does, but this is also going to be a question that why they are even important. So if you talk about companies like Google, so what they do, they use web crawlers so that they can download and organize data from the internet. So this is going to be helping them so that they can build a searchable index of all the websites, so that if you want to search for something, like let us say on the Google you are writing something like Apple, you must have seen the moment we write something and we press enter, what it does, it will be quickly showing you all the results related to that. All of those things happens within fraction of seconds. And how Google was even able to build that, so in their search engine what they have done, they have used web crawlers so that they can collect the data from all over the internet, and later on they are indexing them so that whenever we are going to be searching something, it will be very easy. It can provide you results in the less amount of time, but at the same time, if you will see, they have saved a lot of amount of data in their uh, servers, correct? Now, what is the goal of web crawler? So when you talk about web crawler, so its major goal is visiting different websites, as many websites as possible, and download their content. So now we will just be discussing how a web crawler is working, how Google is using them, and how the resources, like, what and all are the resources which we need so that we can save that much amount of data, like a vast amount of data. Okay. So, like, let us say I'm giving you a task. You, as a user, is having a task that you will be going and download all the data. Like, we will be like, I'm asking you that download all data from internet. So this is your task. Now, in this particular one, what we will be doing, Google is going to be like, Google is actually using this web crawler thing only so that it can go ahead and perform this. Like what Google does, like basically it crawl all the websites, collect their data, and save it there. Okay. And exactly the same task I'm giving it to you. So, like, have you ever thought, like, the moment we just do enter on Google, how we are able to even see a lot of search results, that too so quickly? Like, if you have used database, so you must have seen when we have less amount of entries and then we try to retrieve some of the information, it is quicker. But the moment we add more data to our database, eventually the the queries are taking longer time. But if you will see, Google is storing huge amount of data, but still it is able to deliver all of the search results in a fraction of second time. So have you ever thought how the Google is even able to provide search results to you so quickly from such a vast amount of data? So Google has actually perform this web crawling so that it can visit the different websites, download their content, and organize them into a indexed database. Now, whatever the downloaded data they have, they are further indexing them so that they can allow users to search from their information quickly. So this process is ensuring that Google can provide results in fraction of second, even from a massive data set. Now, you have understood what the problem statement is. Now, your next requirement is how, like, you need to even determine, when I was initially telling you what and all decisions you need to take here, you also need to determine what amount of storage you are going to be using, how you are going to be computing all that data. For this purpose, what and all you are going to be doing. Okay. Yeah. So now you will like, first thing which is there is, if you want to download all the data from the internet, you should be knowing how many websites do you have. So how many websites are there in this world? So the number is approximately 2 billion, correct? Now, with these many websites, if you will see, a quick Google search will show you results which are close to 2 billion, correct? Because from all of those websites only, it is searching and providing you the results. So this number is expected to grow over the period of time, because if you will see, with the advancements, with everyday like arising needs and the requirements, if you will see, the websites are something which are increasing every day. So if today we have 2 billion websites, tomorrow we may have more than that. Okay. Now, if you talk about any of the websites, so these websites are going to vary in size. Some are going to be a single page websites. Some are going to be like Wikipedia, where we will have thousands of pages, and many will have some few pages, like 2 or 3 pages. Now, let us assume that total average number of pages, average number of pages per website, let us say it is 100. Okay. Now, if you will see, how many pages are we actually covering? So we have 2 billion websites, and every website is having 100 pages. So total we are going to be having 200 billion pages, correct? That is what we are going to be having. Now let's assume the average size of each page. Average size of each page is, let us say, 100 KB. Okay. Now what will happen? We will have to see what is the total size of the content. So if you will be seeing total, we have 200 billion pages, correct? And every page is of 100 KB. So this is going to be the total size of the content, right? You can also go ahead and write it something like 2 into 10 power 4 billion pages, or like, since we are talking about memory, let's talk about KB. So this is the total size which we are going to be having. Now, since it is in KB, let's convert it into bytes. So we will be having 10 power 3 bytes, correct? Now, so total, the total size of the content, how much we are going to be having. So that is going to be 2 into 10 power 7 bytes. So this is going to be the total size of the content which we have. Now, when you talk about 2 billion bytes, so what is that? So that is somewhere like now we are just calculating it. So if you talk about 1 gigabyte, so how many bytes you are going to be having in gigabytes? So that is going to be 10 power 9, right? Now, if you are going to see, we initially had this 2 billion into 10 power 7 bytes, correct? So let me just, one second. So what we will be doing, let's just convert this even from billion. So if you are just going to be removing this billion, so this is going to be something like 10 power 9 into 10 power 7 bytes, correct? Because 2 billion bytes are equivalent to 2 into 10 power 9. And this is something which we are using directly here. Now, if we talk about 1 GB, so that is going to be having 10 power 9 bytes. So if we are going to be further dividing it down, so how it will be there? So this will become 2 into 10 power 9 into 10 power 7, divide by 10 power 9, and then from bytes we have now converted into GB. So if you will see here, we are having 2 into 10 power 7 GB. Now, if you want to further divide it into TB, so how you will be able to do that? 2 into, since 1 TB is going to be equivalent to 10 power 4, correct? Sorry, 10 power 3, 1024, right? I'm just using some rough values here, okay? Approximated. So if you have this, so this will get converted into 2 into 10 power 4 TB. So this is the data. Now, if I want to further convert it into petabytes, so petabytes. So how I will be doing it? 2 into 10 power 4 divided by 10 power 3. So if you will see, this will be becoming something like this. So we have 20 petabytes data. So you can see from 2 billion websites, this is the total amount of storage which we will be requiring in order to save all our data. So if we are having machines, so if each machine can store 1 TB of data, like, if we have a machine storage, let us say it is 1 TB, like that is again pretty much high only. But if one machine can store 1 TB of data, so how many total machines we will be needing? So that is going to be 20 petabytes divided by 1 TB. So roughly we are going to be using 20,000 machines. So that is like, we are going to be needing so many websites in order to store all the data which is available all over the internet. So if you will see, if we want to collect all the data, how much total data we will be having, that is going to be approximately equal to 20 petabytes. And how many machines we are going to be using? Approximately 20,000 machines having storage of 1 TB each. So that is going to be the total amount of storage which we will be requiring if we will try to web crawl all the website data. So now you have seen that in order, like, if Google is storing all that data, so they need some massive infrastructure in order to store that amount of data from all over the internet. So with this setup, only Google can deliver such results at the lightning of speed. Now, like, we have actually taken care of three things here. We have done requirement gathering. What was our requirements? That was to collect the data from all across the internet. The second one is scoping, where we are dividing the entire task into smaller tasks. The third step, which we have taken care, is estimating the data size. And here, three things which we are taking care. So the first one is the storage. How much storage you are going to be needing for storing the entire data. Now, after storage, you are going to be further performing some of the computation. And later on, you will be needing some network so that all the devices can interact with each other. So these things which you are going to be requiring. So now, once this is done, the next step is going to be breaking the entire system into smaller components. So this approach is actually inspired by a real life scenario. So let us say you are actually hosting a party. Okay. Now, if you are the host and if you want to have a party, for that you will be like, if let us say you are some 3 or 4 members of family. So now what you are going to be doing, you are going to be splitting the work among everyone in that family. So what you will be doing, to one person you are going to be assigning a task. Like let us say you will say, okay, you go and you welcome the guests. To the other one, you are going to say that you go ahead and you take care of the food. To the third one, you will say that you go ahead and take care of what gifts to give it to them. And to the last one, you will say that you take care about the comfort, that everyone feels comfortable there. So let us say this is how you have split it up. So instead of you single-handedly taking care of all the things, what you are doing, you are assigning specific tasks to each of the functions. So by dividing the work, everyone knows what their responsibilities are, and they know that whatever task they have, they can carry it out in a streamlined and efficient manner. So this is the same principle which when we apply to a bigger system. So instead of solving the entire problem in one go, what we can do, we can break it down into smaller components. And how that is going to be helpful? It is going to be helping us in order to organize and manage the process effectively. So similarly, when we build a large project, instead of creating one big monolithic application, if we try to break it into smaller manageable components, then it becomes easy for us. Okay, let's take the example of Amazon. So when you talk about Amazon, let us say you're working on a feature which allows user to buy an item. So this is your task. So instead of writing down code in single massive application, what you can do, you can split the functionality of that into smaller services. Each one is going to be handling specific part of the process. Like here, you can create one placeholder cart. What this cart is going to be doing, this cart service is going to be managing the user's cart and all of relate like and all other related information there. The next one is going to be the checkout service. What this checkout service is going to be doing, this one is going to be managing the payment, and here we are also going to be taking care of the purchase process. We will be handling the checkout process here. The next one is going to be inventory service. So what inventory service has to do? This one is going to be keeping a track of all the available items. The next one is authentication service. So you will also have to ensure that the user is logged in and has the proper credentials. Then only it will be like, possible for you to have all the information related to that person stored. The next one is going to be the payment service. And this payment service is going to be taking care of all the payment transactions. The next one is going to be the shipping service. So once you have placed the order, the next one is going to be ensuring that you are processing the shipping and you have all the delivery related details handy for you. So by dividing all the system into in these smaller and focused applications, you can easily manage development process more effectively. You can make your approach, you can make your system more scalable, and you can even simplify the maintenance. Like you will not be like if you are just making some changes at the cart level, you are only going to be modifying that code. You are not going to be touching the entire code base. So this modular approach ensures that each part of the system can work independently, and still they are even though we have this big application, all or even though we have broken it down into smaller ones, but they all are actually contributing to this big project only, this big functionality. Now we will be seeing how, like if we want to buy anything, how that buying process works. So what will happen, like if you want to buy an item, so if a user wants to buy an item, this process is actually involving several smaller components which are working together, each with a different responsibility. So what is the first one is going to be doing, like let us say you want to buy a product. So once you have finalized that this is what I want to buy, the first thing which you will do is adding to the cart. So here what will happen, user is going to be adding that product to their cart, and who is going to take care of this? Here I have already specified different services we are going to be using here. So out of this we are going to be using your cart service. Now the next one is going to be initiating checkout. After you have added it, the next one is going to be checkout. For checkout, what we are going to be using, we have checkout service. So after taking care, like what will happen, this card service is actually going to be communicating with the checkout service so that it can go ahead and start the payment and the buying process. So here we will go ahead and call the checkout service. Now after this, what is going to be the next one? If you want to buy something, we always need to go ahead and go to the authentication. Like if you want to buy some item, they will ask you that either you buy it as a guest, or if you have credentials, go ahead and log in. So the next one is going to be the authentication. For authentication, we have this authentication service. So what will happen, this checkout service is going to be like going to be calling this authentication service, that first you authenticate and then you proceed ahead with buying your item. And this one is also going to be verifying the user identity, and this will ensure that the customer is valid and they have some valid credentials. Yeah. Now after this, what we will be doing before proceeding the checkout, we will be going and checking the inventory. Because if some item is available, like sometimes you must have seen, even if some item is there in your cart, but by the time you go ahead and buy it, it will show that now the item is out of stock. So adding an item to your cart doesn't guarantee that you will be able to buy it. It all depends upon the inventory. And in order to perform the inventory check, here if you will see, we have one associated service, that is your inventory service. So this one is going to call your inventory service. This one is going to check that if item is available or not. If item is not available, it will just let the person know that it is out of the stock. Once it is available, then only you will be directed to the payment process. So then we will be processing the payment. In order to process the payment, we have one associated service, that is the payment service. So what will happen? The checkout service is going to be communicating with the payment service so that we can handle the payment. If the payment is successful, then the process will move to the next step. And what is the next step? The next is going to be shipping part. So when you talk about shipping your order, so here, what associated service do we have? So for that, we have some shipping service available. So here we are going to be using shipping service. So finally, your checkout service is going to be calling the shipping service to arrange the shipment and delivery of the order. Now, if you will see, what are we actually achieving here? Although we have written down all the services and all, but what is the thing which we are achieving here? So you can see we had a single problem statement, that is to buy an item. We were just doing that task, but what we have done, we have broken down the entire task into smaller and manageable components, and each of these services is actually focusing upon a specific task, and later on all of these services are communicating with each other to complete the process. And what actually happens when we perform it in this way, we make our system more organized, more scalable, more maintainable. So by breaking down the problem and, defining the clear interaction between the components, the overall functionality becomes more streamlined and efficient. So when you actually so far but and all we have done, we have gathered the requirements, we have done the scoping, we have also done the estimation, and we when we are doing this estimation, at that time we are performing this planning, and this planning is going to be breaking it down that what and all service we are going to be needing so that we can achieve our target. So when we build any of the large projects, so instead of creating one big application, we try to break it down into smaller components. Okay. So when you are working on some feature like buying an item, so at that particular time, instead of writing all of that code in one place, what we do, we try to break it down. And how we do, these are the different services which we are going to be using here: the cart service, checkout service, inventory service, authentication, shipping. All of these things are going to be taking care of different responsibility. Your cart service is going to be taking care of all the cart related information like adding or removing items from the user cart. The checkout service is going to be managing the checkout process, where we are going to be summarizing your order. We are also going to be confirming your purchase details. Your inventory service is going to be taking care of availability of the item and what the stock levels are there. Sometimes they will also be telling that okay, only 2 items are available in the stock. Like all of those things are taken care by the inventory service. Then we have authentication service, which is going to be verifying the user's identity. If it is a if we are entering the correct credentials only, it will let us proceed ahead with the purchase. After that, we have payment service, which will be processing the payment securely, and this will also confirm the transaction status. Then we have shipping service. So this one is going to be taking care of the order shipment, and it will also be taking care of the delivery to the customer. So by dividing the system into smaller components, each service can focus on a specific task. These services can later on interact with each other so that we can complete the delivery operation. Now, what is the benefits of this approach? It makes our system scalable. So individual services are there which are scaled individually, independently. We are not if later on if we want to make changes at one level. We can just do it individually. It's not tightly coupled, it is loosely coupled. Next is maintainability. So if you want to debug and perform any of the updates, so all of those things are easy because every service is isolated. There is zero dependency on each other. Next one is flexibility. So here developers can work on different service. Like, we will have different teammates and we can just assign each and all responsibilities separately. Like one individual can work on one service, and that way there will be zero conflicts. They all can work down separately. So by breaking it down into smaller and interconnected solution, we can simplify our project management, and we can also ensure the delivery of this feature correctly. Okay. Now we will quickly see that for buying an item, how all these services are communicating with each other. Although I have told you verbally, but with the help of a diagram, we will see how the communication is going to get made. Okay. So for the Amazon, like what our task was there, that user should be allowed to buy an item. So that is our task. So for this, what and all services we are going to be having? We are going to be having a cart service. The other one, we are going to be having checkout service. Next one, we are going to be having authentication service. Next, we are going to be having inventory service. One, we need payment service. And we are also going to be needing something called as shipment service. So these are going to be the different services which are going to get involved if a user wants to buy an item. So if we have a user here and this user wants to buy an item, so these are going to be the different services involved. So how this entire buying process is going to be working? So this one is the user. So what will happen when the user wants to buy an item? The process starts with adding an item to the cart. So for that, we are going to be making use of our cart service. So firstly, the user is going to use the cart service. This cart service is going to be responsible for taking care of the task of adding an item to the cart. So this one is going to let the user add items to their cart and also manage the cart's contents, like what and all items are there, how many quantity we are adding there. So all of those are going to get add there. After adding the items there, the next one, like this cart service, is going to be calling your checkout service, and this checkout service is actually going to be taking care of all the checkout process. This will be taking care of the payment, and this is also going to be helping you to proceed ahead with buying this item. Now after this, what will happen? This checkout service is going to call the authentication service. So it will go to the authentication service and it is going to be verifying the user. It is going to be authenticating the user. If, like, if we are having a successful authentication, if the user is entering the correct credentials, so what will happen? This authentication service is going to reply back to the checkout that yes, I have authenticated this user, this has a valid credentials, and after this you can move ahead. So once this is done, once the authentication service approves the user, then it will come back to the checkout service, and after that checkout service will perform the final check to ensure if the item is available or not. So in order to perform that, checkout service is going to be calling the inventory service. This is going to be confirming whether the item is there in the stock or not. Now, once the inventory service is confirming that the item is available, then what will happen? It will reply back to the checkout service that yes, the item is available, you can proceed ahead, and this will let the user to complete the process. So after this, the checkout service is going to be calling the payment service. So after this, we will come to the payment service. In this, we are going to be processing the payment for the given item. If the payment is successful, then it will be calling the, it will reply back to the checkout that yes, the payment is successful. Then it will call the shipment service that okay, now we should proceed ahead with initiating the shipment process, and this will also be taking care of the delivery of the item. So what we are doing here, if you will clearly see, we had a single problem statement that was allowing the users to buy the item. So what we have done, instead of doing everything in one go, we have broken it down into different components, and this process is also giving a clear uh, design layout that how this task is actually going to get performed. So what we have done here, we have clearly broken down the everything into this format. So, if you will see, whenever you talk about any of the theories which you have already covered as a part of your curriculum, so there they will be telling you what and all are the different steps which are involved whenever you are designing any of the system. Now, I'll just quickly tell you how does it even happen here. Okay. So, when you talk about system design, so you know what and all are the two components which are involved here. The one is your low level design, and the other one is your high level design. Also, what and all are the different steps which are going to get performed here? Yeah, now what and all are the steps which are involved here while designing any of the system? So the first one is going to be the requirement gathering. Once you have gathered the requirements, the next one is going to be the scoping, where you define the timelines about when you are going to be delivering which component, when you are going to be performing the testing for that. So all of those things are how you are going to be scoping down your work. So all of that is going to be coming here. After this, the next step is going to be estimation. So this estimation is going to be performing three things here. It is going to be calculating the data size because you are going to be storing it out. So first one is storage. The second one is compute. The third one is network. So all of those things are going to be coming here. After this, you are going to be discussing the components. Like here we have discussed what and all services we are going to be requiring. So after this, the next one is going to be the components. Then once we have finalized the components, then we step into the implementation. So you have seen we have followed 4 steps, and so far we haven't done any implementation yet. Once you have finalized your components, you will go ahead and start the implementation. Once you have implemented your code, the next one is going to be the testing process. You are going to be sharing your code with the testing team that you go ahead and test it out if it works correctly or not. If there are going to be certain bugs, we are going to be addressing them. Otherwise, we will be moving to our next step. And what the next step is, that is going to be your deployment. So if you will see, these are the different steps which are going to get involved here. And now, since I said in the system design, we are having 2 levels of designing. So how we actually break it down? So these initial 4 steps, where you are gathering the requirements, where you are scoping it out, where you are performing the estimation, where you are determining the components. So all of those things are a part of your high level designing. And if you will look at the remaining steps where you are implementing it, where you are testing it, where you are deploying it. So all of those things are going to be coming as a part of your low level designing. So this is how it is going to be there. That is why when we talk about low level designing, here we generally talk about design principles and design patterns. On the other side, when we will be discussing about high level designing, there we are going to be talking about how we can scale our system, how we can make the performance better, how we can perform the partitioning and other things. So that is how it is going to be there. So that's all I had for this module. Now we are going to be meeting in the next module. Till then, happy learning. Bye bye.